So hello, my name is Julie Hlavacek-Larrondo. I am a professor of physics at the University of Montreal, and I hold a Canada Research Chair in observational astrophysics of black holes. So today I'm going to talk to you about a fantastic discovery that was revealed. So it's the first image of the black hole at the center of our galaxy. And so the first question that we can ask ourselves is, why is this exciting? Why is this such a big discovery? And so the first thing to remember is black holes are really, extreme, super mysterious objects. They're the most extreme objects in the universe. They're so compact and so massive that their gravity is so extreme that nothing can escape, not even light. That's why we call them black holes. And so they're, in a way, they're invisible. And so to be able to take an image of an object that's invisible, it's so fantastic to be able to do that. And we have the technology to do that now. And so what the Event Horizon Telescope collaboration did was they assembled a huge telescope the size of the Earth. And so they placed antennas all over the Earth. And by doing this, you mimic a telescope the size of the Earth. And so they were able to have an image that has such a good resolution, you can see so many details that they were able to pin down and image the black hole. So what do we see in the image, basically? Okay, so we see the black region at the center, which is the horizon of the black hole. So this is the region within which nothing can escape, not even light. And a lot of people say, then why do we see this ring of like orange stuff around the black hole if the black hole should be dark? So what we're seeing is at the center, we do see the black hole, which is dark, nothing can escape, not even light. But what happens is that this black hole, because of its extreme gravity, is going to be able to capture matter. So matter's like gas, interstellar gas. And by doing this, the gas goes in orbit around the black hole. When it does this, it's going near the speed of light. It gets really, really hot. And by becoming very hot, it emits a lot of light. And this is what we're seeing, is this ring of light comes from the gas that's orbiting right outside the black hole just before it falls into the black hole. So that's what we see in the image. Now, why is this image scientifically, so interesting, besides being awesome, just seeing, the invisible? So the first reason is black holes being so extreme, they're really fantastic laboratories to test gravity, like the best constraints on gravity that we have, in particular for general relativity. The size of the black hole depends directly on its mass. And we had a constraint on the mass that we were able to get from orbits of stars that are much further away. So this was done by two teams of astronomers about 20 years ago. They looked at the orbits of stars, and by looking how fast they were going, they determined the mass of the supermassive black hole. And so we already knew the mass of this object. So we had an idea of what its size should be if general relativity was correct. And so they compared this prediction to what they see in the image, and it fits perfectly, like right down to the pixel. It fits really nicely. This means that general relativity seems to work really, really well, even in the most extreme gravitational systems. What's a bit more mysterious, and this for my research is really interesting, I like to understand, how black holes work and what their impact is on galaxies. To understand that, we have to understand how they are able to attract matter and how this matter goes in orbit around it. And the black hole at the center of our galaxy is a bit special because it's actually kind of on a diet, on a very, very strict diet. It's not, there's not a lot of gas around it, so it hasn't been able to capture a lot of it. On a human scale, it's equivalent to a human eating 1 grain of rice every million years. This is how much the black hole is eating at the center of our galaxy. So it's really on a diet. And we thought we understood like the physics of how this mode of accretion works for black holes, but our predictions do not match what we see in the image. So this means that there's new physics that's missing. We don't understand exactly how that works. So that's super interesting for my work. And so I'm looking forward to understanding that in more detail. Now, one question that a lot of that we got a lot from everybody was, why did they image this black hole as the second time, whereas 3 years ago they were able to get the first image of another supermassive black hole, which is located at the center of a big galaxy called M87. And the reason for this is because that black hole, which is located in the galaxy M87, is much bigger. It's about 1,500 times bigger than the black hole that's located at the center of our galaxy. This means that since it's bigger, the orbits of the gas that it's able to capture are larger because the black hole is larger. And so since the orbits are larger, the time it takes for this gas to make one complete orbit is a couple of days, versus the black hole at the center of our galaxy, which is much smaller. The time it takes to do one orbit is a couple of minutes. And this makes that getting that image for the black hole at the center of our galaxy much more difficult, because when you're observing this black hole with telescopes over timescales of hours, even days, this stuff is moving around on timescales of minutes. And so you have to incorporate that in your analysis, and it makes it much more difficult to extract the image because there's so much activity going on near that black hole. That's why it took so long to get this image. Now, what's happening in the future, what's the next big step for the Event Horizon Telescope? It's actually related to the fact that these orbits are much smaller. Everything's going around much more quickly, much faster in time scales, is that because things evolve on minute time scales, we could actually produce a video. And that's what the collaboration is aiming to do, is not only get an image of a black hole, but actually get a video of how this matter is going and swirling around the black hole at the speed of light. And so that's one of the goals that they're planning on doing. And to do that, they're going to have to upgrade the telescope, put more antennas. And so stay tuned for those results in the next couple of years. Thank you very much and have a great day.